Okay, so we are going to see about equations for star to delta transformation. Okay, star network, otherwise known as Y network to delta transformation. So this is a star network which has resistance Ra, Rb, Rc. It looks like the letter alphabetic letter Y, hence it is known as a Y network. This is delta network A, B, C joined together makes a delta network which has resistance Rab, Rbc and Rac. This arrow mark indicates conversion of star network to delta network. Okay, here output does delta network parameters Rab, Rbc and Rca. So these three parameters we are going to derive from delta, star to delta transformation with the help of Ra, Rb and Rc. Okay, already we know that from delta to star transformation we derived equation for Ra, Rb, Rc. These three equations already we know that. Mark these equations. One, this is equation number one. Equation number two, then equation number three. Three equations marked 1, 2, 1, 3. Okay, so now we are going to do the derivation. First, divide equation 1 and 2, which means divide Ra by Rb. Okay, divide both left hand side and divide both right hand side. So Ra by Rb is equal to, see both Rab, Rca divided by Rab, Rbc. Ra by Rb is equal to Rab, Rca divided by sum of all resistance whole divided by Rab, Rbc divided by this term, which means first equation divided by second equation. Okay, now both denominator will be same, hence gets cancelled. In the numerator, Rab, here also Rab is present, so that Rab is also cancelled. So we will get Ra by Rb is equal to Rca divided by Rbc. Okay, see, I am going to calculate RAB, RBC and RCA, okay, delta connection. For this RA by RB equal to RCA by RBC, I need the value of RCA. Hence, this RBC goes to that side, means we will get RCA is equal to RA by RB into RBC. Okay, mark this equation 4. Okay. Next, divide equation 1 and 3. RA by RC. RA by RC means RA by RC. RA by RC. So this right hand side we will divide. So this two denominator gets cancelled. RCA and RCA gets cancelled. Finally, we will get RA by RC is equal to RAB by RBC. I need RAB value. RAB is equal to RA by RC into RBC. This divided term goes to that side, means it goes to product. RA by RC into RBC. Mark this equation as 5. Okay. Now substitute equation 4 and 5 in 1. Substituting the equation 4 and 5 in RA or 1, equation 1. Okay. In equation 1. Okay. So substitute equation 4 and 5 in 1. What is equation number 1? Ra is equal to Rab, Rca divided by Rab plus Rbc plus Rca. Now substitute the value of Rab and Rca in equation 1. Okay. Ra is equal to, in the place of Rab, I will substitute Ra Rbc by Rc. Rc in the place of Rca, substitute Ra Rbc by Rb. In the denominator also we will substitute Rab and Rca value. Okay. See the numerator here. There is no addition term. Only it is in product. Both terms are in product. So I will directly multiply two terms. Ra into Ra R square, Rbc into Rbc Rbc square divided by Rc into Rb, Rc Rb. I'll write as it is. Okay. See the denominator here. We are having addition plus term. Okay, plus term. When plus terms will come, what we are going to do? Taking LCM. Okay, taking LCM means LCM denominator is Rc Rb. See this one term here Rc. So in the numerator we are going to product with the Rb. So we will get Ra, Rbc, Rb. Here there is no term, so divided by 1. We can consider 1. 1 into Rb, Rc now. In the numerator we will product Rb into Rc. So RBC into RB into RC plus here in the denominator we will have RB. So product with the RC here, RARC into RBC. Okay. So this is the equation. From this equation, RBRC gets cancelled, which means both the denominator will get cancelled. See this term here. Three terms having RBC as common. So take RBC as common. Then you will get RA, RB plus RB, RC plus RC, RA. Okay. See, this square and this RA gets cancelled. This square and this RBC gets cancelled. So you will get 1 is equal to RA, RBC divided by RA, RB plus RB, RC plus RC, RA. From this equation, I need the value of RBC because our output is delta network. So I need RBC. I need RBC means RBC is equal to this denominator goes to that side means this RARB plus RBRC plus RCRA into 1. Which is RARB plus RBRC plus RCRA. This RA is in product. It will come to the left hand side means it will come in denominator divided by RA. So this is the equation for RBC in delta network. Okay, see RBC means in the delta to star, already I told all parameter denominator, which means RAB, RBC, RCA denominator will be same. Okay, but here in star to delta, numerator will be same. Okay, in the denominator, this is RBC. There is no in the left hand side, no A in the left hand side, only BC. But in the output, we will get RA. Which term is not in left hand side? That is the answer in right hand side. Similarly, I will write for RAB. RAB means numerator will be same RA, RB plus RB, RC plus RC, RA. Here you will have AB, hence I will write here C, RC. Here CA, hence I will write RB. So this is the answer for RBC, RAB and RCA. Okay. Similar, if you need to derive for RAB, RCA means same thing. Here we will have answer for RCA and RAB. Now finally divide RB by RC. You will get the answer for RBC. Now then substitute all three parameters in equation 2 and equation 3. You will get the answer for RAB and RCA. So these are the equations are the parameters of delta connection in terms of star connection. So these are the equations for the RAB, RBC and RCA in terms of star connection.